Now let's pick up where we left off introducing the elements of quantification theory. So we've already analyzed propositions into subjects and predicates. The subject is an argument that goes in, as it were, in the function, or is given to the function. The function, the predicate serves as a function, and we can illustrate this with our familiar example, blank has a headache. So when we use a variable, it essentially just tells us what the predicate is. Blank has a headache, and that's because x is not assigned a specific value. When we put a constant in as the argument, then it generates an actual proposition, an assertion about the world. So in this case, h of n represents the proposition Matthew has a headache. So it's important to see the difference between these two. In this one, with a variable, we have not said anything about what goes in the x. And so consequently, we can't treat it as an actual assertion about the world. What we want to do now, though, is we want to look at what goes in the quantification spot, as it were, that allows us to analyze sentences like all cows are mammals, or some cow is a Jersey. Okay? So let's talk about the first case of universals. So let's think about the proposition all cows are mammals. That's a concrete proposition. It's an assertion about the world. Its schema is all S is P. Now notice that S and P are variables, so this is a propositional schema, so it doesn't actually tell us anything about the world. It just tells us about the form that possible propositions could have. So, in the proposition all cows are mammals, there are several things going on. If we separate off the front part here with the quantifier, we can analyze it using our elements of subject and predicate, where C is the subject and the predicate blank is M. We'll let that be represented by M. So M of C stands for the proposition C is M. Or in other words, cows are mammals, right? So far, this expression, M of C, is like H of X or H of M in its form. It basically uses the subject and the predicate to represent an aspect of the form of the sentence. In this case, the aspect is the whole sentence because H of M stands for Matthew has a headache. In this case, we don't have the whole sentence because we need to do something with this all out here. So we're going to have to figure out what we can do to represent that all. And so here's the way we do. Instead of thinking of this as a single assertion, in the case of the universal, let's think of it as two different assertions. And these two assertions are actually about what things could be. So let me explain what I mean. Suppose we interpret the expression all C is M, all cows are mammals, to mean this. For anything you can think of, if that thing is a cow, then that thing you're thinking of has to also be a mammal. Now, how would we think about that proposition if we thought about it like this? For anything you can think of, if that thing is a cow, then that thing is a mammal. Well, how we could think of it is like this. We could make C, being a C, we could make that into a, let's change this to X, to make that into a predicate like this. C of X stands for X is a cow. Okay? So now we have two predicates. We have C of X, X is a cow. We have M of X, X is a mammal. So then what we can do is we can say, for any X, for any x. What does that mean for any x? For any x means, if for anything you can think of, let's stick it in the x slot as its argument. And let's say that if that x is a cow, then that x is a mammal. So here's a partial formalization of this proposition that draws on the analysis that we gave, where we took the same basic idea of subjects and predicates and we applied it to both the C and the M in this original proposition. And why did we do that? We did that because now we're a step closer to the meaning of the assertion, all cows are mammals. Okay? This is the crucial part. The crucial part here is using two predicates instead of just one predicate and connecting them together with material implication, because this is the part that's going to give us the quantifier that corresponds to all in the categorical proposition. How does that work? Well, think about it. For any x means anything you stick in x as an argument is going to be tested in a sense. Is it a C? If it is a C, in other words, if what you stick in for x is a C, is true, then go on and say that that thing that you stuck in, that you just stuck in for C, that you just stuck in for x that is a C, that thing also has to be an M. That's what gets us the meaning of the proposition, all C's are M's. Because, in fact, that's what all C's are M means. It means if you have anything that is a C, then that thing you have also has to be an M. So it only remains for us to come up with a symbol for this part of the proposition. And I'm going to use a very traditional form of notation, goes way back, and basically it uses an upside down A to stand for the universal quantifier. So the upside down A basically means for any x. Now, it doesn't have to be x, it can be any variable, for any y, for any z, for any whatever. But we're going to use x because, we use x, y, and z. So what this stands for is exactly the same thing we have written here, for any x. So we put that in parentheses, and then we have another set of parentheses that tell us the scope of this universal quantifier over x. In other words, this universal quantifier has jurisdiction over every x between these two premises. And what do we put in here? We put C of x implies M of x. So now let's read this whole thing and see what it means. The upside down A stands for the same thing as for any, and here's our variable x. So for any x, if x is a C, so that's where the if of the material implication comes in, then x is an M. Now think about it. Pick some random argument for x, stick it in here. If it turns out to be a cow, then it also turns out that it has to be a mammal. That's exactly the meaning that we were trying to capture in our original proposition, all C's are M's. Okay? So now let's generalize this. Anytime we have a categorical proposition in the universal affirmative form, it's going to follow this same basic pattern. We're going to have a predicate for the subject term. It makes the subject. We're going to have a predicate for the predicate term. We're using predicate in two different senses here. The predicate, this P is the predicate in the sense of categorical logic. This is a predicate. S and P are both predicates in the quantification theory sense, right? These are connected by an implication, material implication. They go inside the scope of a universal quantifier over the variable that's inserted. So what do we have here? We have for any x, if x is S, then x is P. Or, in other words, all S's are P's.